Okay, so the first thing I want you to do is write up top on your whiteboard these words. A log equals the exponent. Or a log is an exponent. Or whatever. Okay? Because that's okay. That's one thing about logs is a lot of people don't know what a log really does. It's just the exponent. It's just the exponent. So I want you to show me some things here. If I say the log base 2 of 8, show me what that answer is. See, I'm testing some background here, seeing where you're at. Nope. Yes. Yes. No. Yes. No. Yes. Yes. Okay. So here's the deal. You know, we could do lots of different things, but if we called this x, what this means is 2 to the x equals 8. So what are we trying to find? We are trying to find the exponent. Okay? Well, all we're doing is we're finding the exponent. It's log is equal to the exponent. So we're starting at 2. My base is 2. What I'm going to end up with is 8. What exponent will get me there? It's going to be 3. Okay? So all you've got to ask yourself is, that base, what power do I have to raise it to get the result? Okay? So obviously here, x equals 3. Here we go. Try to do this one. I think this was the bonus. Show me. Good. Nope. Yes, yes, yes. Yes, yes, yes. Yes, yes. It is just the exponent. The exponent that gives me, so we're asking 5 to the what gives me 25. It will just be 2. Okay? Because actually, if you think about it, what we were just doing the last section, when we were dealing with this, I'm hoping I can have you guys summon the maturity to work with whiteboards. That'd be fun. So this one, you were changing the exponent to get different results. Well, now we're flip-flopping it. We're doing the inverse operation. Okay? I know my result. I know where I started. I want to know what exponent I'm going to do. Okay, here we go. Let's just raise the bar a little bit. Log base 6 of 6. Show me. Yes, yes, yes. Yes, yes, yes. Yes, yes, yes. Or you could write it and show me. Okay. Yes, the answer is 1. Okay. The answer is 1. So we could write this rule. The log of any base b, and that being the result, is always 1. That's always the case. Okay, here we go. Log base 7 of 1. Yes, yes, no, no, no. Yes, yes. Okay. Because some of you guys had, it's going to be 0. Okay. 7 to what power gives me 1? Well, anything to the 0 power gives me 1. The answer that some of you guys had to start off with was 1/7. 7 to the 1/7 is actually the 7th root of 7. Okay? So that's why that's not the correct answer. Okay? So we can make another rule to go with this. The log base b of 1 is 0. Okay. I'm going to try something different, see where you're at. The log of 100. Nope. Nope. Okay. By asking you questions like this, I'm trying to see what you remember, and this, that, and the other. Okay. Great point. There's no base. So this is what's called a common log. Okay? Anytime you have a common log where there is no base, your base is 10. Okay, now answer the question. Yes, yes. No, 10 to the 10th isn't. See, if you think about it as an exponent, then it kind of makes you, oh, that was silly. Okay? Good, good, good. No, because 10 to the 0 power gives me 1. Okay? We are asking ourselves, 10 to what power gives me 100? Well, it's 2. Because 10 to what power gives me 10 to the second? 100 is 10 to the second. So that would be equal to 2. Okay? Log of 1/10. Perfect. Nice job. Good. Good. No. Because our base is 10. 10 to the 10th is a 1 with 10 zeros. Yes. So this one, think about it. Now, I'm not saying this is easy, but I'm just trying to get you to think about it a certain way. What exponent changes it from multiplication to division? What kind of exponent? A negative. So this is -1. Because 10 to the -1 means I have to divide by 10 to the first. Okay? Okay, let's try some others. Log base 2 of 1/4. Good. 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 Perfect. No. Yes. To the -1. Yeah, okay. There you go. Bingo. There we go. Good. -2. Okay? Because a negative exponent tells us to divide. So 2 to the -2 is the same thing as 1 over 2 to the second, which is 1/4. Okay? So the thing is, whenever you see log, you need to think exponent. Without your calculator, log base 5 of 30. It's between what two numbers? It's between what, write it down, between what two numbers? What two, there you go, good. 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 No. Okay. Well, between what two numbers? Okay. No. Okay. Well, here's how we answer this one. 2 to the first, wow, 2 to the, wow. Good job, Rexroad. 5 to the first gives me 5. 5 to the second gives me 25. 5 to the third gives me 125. So it's going to be between 2 and 3. Because 5 to the second exponent gives me 25. 5 to the third exponent gives me something. If you were going to estimate it, what would you think it'd be? Just verbally, what do you think? 2.08? Did you do it with your calculator, or is that just a guess? I have no idea. 2.2? Okay. Well, let me calculate this here real quick.
Yeah, probably 2.9. 2.9. Or 2.0. Sorry.
2.113. 2.113. Okay. Okay. Let's try a couple more. Log base 7 of 1 over 49. Just reinforcing a couple things here. Just driving it home. Good, good. No. No. 7 to the 7th is a huge number. Yes, yes, yes. Yes, yes. Okay? Another way, here's what you could do. You could rewrite this. Log base 7 of 1 over 7 squared, which is log base 7 of 7 to the negative 2. So then our answer is negative 2. Okay? Log base pig of pig raised to the cow power. Log base pig of pig raised to the cow. Moo. Yes. Oh, no. Negative? No. Negative means I would divide. Exactly. Exactly. Okay. So it's kind of like asking this. It's cow to what power gives, or I'm sorry, pig to what power gives me a pig to the cow? It's kind of like asking this. What do I have to put on to be wearing a hat? A hat. So that's kind of what this one is saying. Cow hats. Okay. Log of 1. Now I can ask you a couple more highly... Nope. Yes, you're right. Yes, yes. Sorry. No. That would mean divide by that. A negative exponent means to divide. Yes, yes. No. Yes. Base 10. 10 to what power gives me 1? 0. Okay? Okay? I couldn't see that. Okay. No. Log base 7 of negative 7. Nope. That's 1/7. That's 1/7. Nope. Nope.
Oh.
Nope. That's 1/7. Okay. That's 1/7. Nope. 7 to the 1/7 is
Yes.
No, that's the square root of 7.
Give me some square root.
Okay. Okay, so let's do a little investigation. I'm trying to stretch your brain a little bit. Okay. 7 raised to what power? And then we will go ahead and I'm going to pick different values of x. And so 7 raised to the first power equals 7. To the second power, 7 to the second is 49. Am I going the right direction if I'm looking for negative 7 as a result? I'm not going the right way. So let's go the other direction. 0. 7 to 0. 1. Okay, negative 1. 7 to the negative 1. No? Okay, okay. Shh. Take a deep breath. We've already done problems like this, so just think about this. 7 to the negative 1. 1/7. That tells me I'm going to divide now instead of multiply. You guys know negative exponents go on the bottom. Negative 2, what do I get? 7 to the negative 2, which is 1 over 49, right? Negative 3, 7 to negative 3 equals 1 over, what, 343? Wait a minute. Notice, am I ever going to get a negative number? No. So this, no solution, not possible. Okay, so on whiteboard, set them aside for a little bit. Here we go. This is 4.3, I believe. Because there are going to be some things you're going to want written down.
Tuesday and next week?
No, that's the one that you guys took last week. Julie, can you do me a favor? Can you erase that Chapter 3 Tuesday, or Test Tuesday, because people are getting confused, even though that's one we've already taken. Thank you. Okay. 4.3. Logarithmic functions and graphs. This honestly is, personally, I think logarithmic functions are really quite critical. If you go into anything even remotely involving finance or even some biology or something like that, you are going to deal with logs. So first thing, log, you need to think exponent. Okay, and if I have this expression, the log base b of a equals x, we need to be able to go back and forth between a log form, that's log form, and then exponent form. So, with what I've talked about before, this means what to the what equals what? B to the x is equal to a. That's what that means. You need to be able to go back and forth. Period. So if I say something like this, 3 to the x is equal to 10, you need to be able to go backwards. What would that be? The log base 3 of 10 is equal to x. You need to be able to go back and forth at will. Okay? Let's do some more barnyard animals. Okay? Well, let's go household pets. Dog raised to the fish equals cat. What does that mean? Log base dog of cat equals fish. Here's the way you guys have done it before, and I would say 99.5% of the student population, you've been taught this thing. Correct? Okay. Personally, I don't like that, but I shouldn't say I don't like it. I just want you to remember that this is the exponent. The rest of it's easy peasy. And yes, that is correct. If you take your base to that exponent, you get that. That is fine. I totally agree with it. But everything I like to do is based on what does this mean? How does it work? Okay? So, on a couple things here, let's back up to this statement right here. Couple things that are really quite important. B has to be greater than 0. Negatives don't work for my base. Okay? There's a couple reasons why they don't work for my base. Okay? I'm just going to go ahead and I'll address the theory real quick. Let's say if I had -2 and I'm doing different powers of let's go x and -2 to the x. Say x is 1. -2 to the first. What do I get? I get -2, right? Now if I go 2, -2 to the second, what do I get? 4. If I go 3, I get -2 to the third. What do I get? -8. Okay? Do you see a problem with that if we were trying to graph it or something like that? We got it bouncing all over the place. Okay, grab your calculator, please. What if I said for my x, I want a 0.5? So negative 2 raised to the 0.5. You got to put parentheses around it, of course. What do you get? Error. Why? Anybody remember? Gold star problem. Anybody want to earn a gold star? Oh, it can be a fraction, but what's it?
It has to be at least 1.
No, because if I do 1/3, negative 2 to the 1/3, what do you get then? Negative 1.2. Okay. There's something about this that it doesn't like. What's another way to write 0.5? 1/2. If I'm taking something to the 1/2 power, what am I asking it to do? What's another way to say that? You're right. What is that?
Square root.
Square root. What's the square root of negative 2? Square root. Square root of negative 2. The square root of negative 2. That's going to be an I. I can't come up with that answer. Okay? So negatives as our base just simply don't work. Because that would be the same thing as if I took it to the 1/10, that'd be the 10th root. 1/8, it'd be the 8th root. So negative, that's just a way to reinforce. B has got to be greater than 0. Okay? And as a result, A is going to be greater than 0. Okay? Anything in these two positions are positive. That's just all there is to it. Okay. One last thing. Graph. Y equals log base 2 of x. Okay. I want you to be able to graph this. This tripped up the pre-calc kids. So make sure that you can do this. Okay? Y equals log base 2 of x. What does this mean? What to the what gives me what? 2 to the y is equal x, right? Okay. This is a little trick that this book taught me. I've never used this method before. I think it's kind of cool. If I go x and y, let's pick y's. If I go 0 for y, what's my x? 1. So on my graph, I have the point 1, 0. What if I put in 1 for my y? What do I get? 2. Now let's go the other way. Let's pretend we didn't see this. If I had the log base 2, give me an x that I know the log base 2 of. 2. It's 1. Okay? Give me another x I know the log base 2 of. 8. So what is 8? 3. To get to an 8, I need an exponent of 3. What about 4? 2. What about 1/2? Negative 1. What about 1/4? Negative 2. So then we're going to have a graph that looks like this. 1, 0. 2, 1. Next one I know. 4. So let's stop right here for a second. I'm graphing all the points I know the square root of, and this is my exponent that got me there. 0, or 1, that'd be 2 to the 0. 2, that'd be 2 to the first. 4, that'd be 2 to the second. What's the next one? 8 would be 2 to the third. Okay. 1/2. -1. 1/4. -2. That's what a log graph looks like. Logs are pretty nice because what's this now? So here we go. It gets closer to 0. But this one, this is actually your decibels rating in your Richter scale ratings are all logarithmic scales, but we might talk about that someday when we have a little extra time. Okay, so here we go. 15 minutes. I want you. This is going to seem like, oh my gosh, she hates us. Well, you might be right, but no. This is just going to be write a bunch of stuff, and it's actually going to go pretty quick. 327. 1 through 27, all. And 31.
Birds.
How's Mr. Burtis doing? Oh, hold on.